Hey everyone, and welcome. So we're about to dive into one of the simplest, but also one of the most profound questions you can possibly ask about the universe. It's a riddle that was hiding in plain sight for centuries, a cosmic detective story where the biggest clue is nothing at all.
I know. On the surface, the answer seems completely obvious, right? It's night. The sun's gone down. But if you think about the universe for just a moment longer, this incredibly simple question balloons into a massive paradox that seriously stumps some of the greatest minds in the history of science.
To really get a feel for the problem, imagine you're standing in the middle of a forest. Now, if that forest is small, you can see little gaps of sky between the tree trunks. But what if the forest was infinite, stretching on forever in every single direction? No matter where you looked, left, right, up, down, your line of sight would eventually hit a tree. Your entire view would just be solid wood.
Okay, so now let's apply that exact same logic to the cosmos. If the universe is infinite and it's jam-packed with stars, shouldn't every single line of sight from your backyard eventually end on the surface of a star? The whole night sky should be a blazing, continuous wall of light, as bright as looking directly at the sun. This glaring contradiction between what we expect and what we actually see, that's known as Olbers Paradox.
And this is really where our investigation begins. See, that darkness isn't just a boring backdrop for the stars. It's a clue. It's a huge piece of evidence telling us that our most basic gut instinct assumptions about the universe might be fundamentally wrong.
So how did we even get into this paradoxical mess in the first place? Well, to understand it, you have to go back and look at the old 19th century view of the cosmos. It was built on four key assumptions that, when you put them all together, made a dark night sky a logical impossibility.
And here they are, the four pillars. First, the universe is infinite in size. Second, it's eternal. It's been around forever. Third, the stars are spread out more or less evenly everywhere. And fourth, the whole thing is static. It's not expanding or contracting. You take those four ideas as true, and you are absolutely forced to conclude that the night sky should be blindingly bright.
And the logic behind this is actually pretty elegant. Just imagine the universe is made of these giant, concentric shells centered on Earth. The farther away a shell is, the dimmer its individual stars look to us. But, and this is the key, that bigger, more distant shell also contains way more stars. It turns out these two effects, the dimness of each star and the huge number of stars, they cancel each other out perfectly.
And this leads to an absolutely staggering conclusion. Every single one of those shells, no matter how ridiculously far away, adds the exact same amount of total light to our sky. So if you've got an infinite number of shells in a universe that's existed forever, you get an infinite amount of light. The entire night sky should be a solid sheet of fire.
But it's not, obviously. And for centuries, this puzzle drove astronomers completely nuts. So many brilliant people took a crack at solving it, but all their clues just seemed to lead to dead ends.
I mean, this mystery goes way back. In 1610, you had Johannes Kepler arguing that the dark sky was proof the universe had to be finite. A simple but not quite complete answer. By the 1740s, folks like Chisholm were actually running the numbers, calculating the sky should be something like 180,000 times brighter than the sun. And then in 1823, Heinrich Olbers, the guy the paradox is named after, made it famous, while also proposing a solution that was, well, just plain wrong.
So this was Olbers' big idea. Hey, maybe there's just a bunch of interstellar dust out there blocking the light. It sounds plausible, right? Space is full of dust. But here's the fatal flaw, and it's a big one rooted in thermodynamics. In a universe that's infinitely old, that dust would have been absorbing energy for an infinite amount of time. And eventually, it would heat up so much that it would start glowing just as brightly as the very stars it was hiding. So nope, that doesn't work. The problem doesn't go away.
And this is where the story takes a really wild turn, because the first person to get remarkably close to the right answer wasn't an astronomer at all. It was, of all people, the writer Edgar Allan Poe. In 1848, he basically reasoned that the only way to explain the dark gaps between stars was if the light from the most distant ones simply hadn't had enough time to reach us yet. He nailed the two key ingredients. Light has a finite speed, and the universe had a beginning. Absolutely brilliant.
Now, Poe's insight was pretty much ignored for decades, but he was absolutely on the right track. And with modern cosmology, we can finally put all the clues together and solve this cosmic crime once and for all.
So here's our evidence board. That dust theory from Olbers, flawed.
The idea that maybe stars are arranged in some weird, clumpy fractal pattern, also flawed. We've looked, and the universe is pretty smooth on the largest scales. Kepler's idea of a finite universe? That was a good guess, partially valid. But the real culprits, the two primary reasons the sky is dark, are the universe having a finite age and the fact that it's expanding.
So here it is, the single most important piece of the puzzle. Our universe is not eternal. It had a beginning, about 13.8 billion years ago. And since light can only travel so fast, we can only see light from stars and galaxies that are within 13.8 billion light years of us. The light from anything farther away than that, it simply hasn't had time to get here yet.
Just stop and think about what this really means. Those dark patches you see in the night sky, they aren't just empty space. They are literally windows into the past. You are looking back to the cosmic dawn, to a time before the very first stars had even switched on. We are seeing the darkness of the beginning.
But wait, there's a second factor that's also crucial. The universe isn't static, it's expanding. Space-time itself is stretching out like a piece of taffy, and as light travels across billions of years of this stretching space, its wavelength gets stretched out too. We call this redshift. It literally saps the light of its energy, making distant galaxies appear fainter, and eventually it can stretch the light so much it gets shifted right out of the visible spectrum and into the infrared and microwave ranges.
So, case closed, right? A finite age plus an expanding universe explains the darkness. Well, almost. There is one final, mind-bending twist to this entire story. The whole original paradox argued that every single line of sight should end on a wall of light. Now, we've shown that it can't be starlight, but does that mean those lines of sight just end in true, absolute nothingness?
And here's the incredible kicker. In a very real way, the paradox was right all along. The entire sky, in every single direction, is glowing. Every line of sight does end on a source of light. We are being bathed in it constantly, right now.
That glow just isn't starlight. It's the cosmic microwave background, the leftover heat, the fading afterglow from the Big Bang itself. It's the light from the very moment the universe first became transparent, a flash of light released when the cosmos was only 380,000 years old.
You see, when this light was first released, the universe was about 3,000 Kelvin, as hot as the surface of a star. It was a brilliant, white-hot fog filling everything. But over the last 13.8 billion years of cosmic expansion, that light has been stretched and cooled and redshifted all the way down to a ridiculously frigid 2.73 Kelvin. That temperature puts it squarely in the microwave part of the spectrum, making it completely invisible to our eyes.
And that, right there, is the ultimate resolution to the riddle. The bright glowing sky that Olbers Paradox predicted actually exists, but cosmic expansion has cooled it and stretched it into a form of darkness that our eyes just can't see. So the dark night sky isn't empty at all. It's full of information. It's maybe the single greatest clue we have that our universe is not infinite, static, or eternal. It tells us it had a dynamic, fiery beginning. That darkness isn't a void, it's a message from the very dawn of time.